A very warm welcome to the second part of the video series on the subject of cable diagnostics. In the first video, we established that diagnostics not only prevent cable faults, but also represent an enormous potential for savings by extending the service life of cables and allowing subsections to be replaced. The final comparison of costs and benefits clarified and visualized the high return on investment in this area. It was possible to disprove the myths that cable diagnostics are expensive and not worthwhile. In the second part, we will provide an overview of the most important standards, introduce measurement methods and their applications, and investigate the myth that cable diagnostics are complex. But first, let us take a look at the situation regarding standards. More and more committees are taking up the subject of cable diagnostics, which has led to some changes and progress in this area. All standards that have been revised in recent years now cover the subject of diagnostics. This has become an instrument used by network operators in the maintenance of their networks. IEC, IEEE, DIN, VDE, and SIGRE represent the most important standards and committees on the subject of cable diagnostics. So what's in the standards and what changes have taken place in recent years? IEC 60502-2014 covers, among other things, testing and diagnostics for distribution networks in the medium voltage range from 6 to 30 kV. An update to the standard led to the inclusion of the 0.1 Hz sinusoidal VLF test method and the recommendation of tan delta and/or partial discharge testing to accompany cable testing. The simple DC test for plastic cables was removed from the standard. Following the introduction of IEEE 400-2012, the VLF very low frequency test method with sinusoidal 0.1 Hz is now also listed in the standard. This is the only method listed for which sufficient experience exists on the market, and that is classified as useful or potentially useful for all application cases. Moreover, the HVDC testing of XLPE cables is no longer recommended due to bad experiences. Following the introduction of IEEE 400.2/2013, the tan delta monitored withstand test was introduced onto the market. This means the performance of the VLF sinusoidal voltage test with simultaneous diagnostic measurement. The committee of SIGRE has also set up a working group on the subject of cable diagnostics in the medium voltage range, thereby assigning more importance to this area. The DIN VDE recommendation for commissioning testing of medium voltage cables includes a VLF voltage test with accompanying PD testing that permits a reduction in the test level and test duration. To sum up, it is clear that all the listed standards include and recommend tan delta and/or partial discharge testing to accompany the voltage test. In the following section, we will introduce the development of the individual measurement methods and describe these methods in detail. The technology in the field of cable testing has been in a state of continuous development over the last few decades. DC testing was used initially, but has been replaced by VLF testing, which only provides information on whether the cable is okay or a fault or breakdown has occurred during the test. It provides no information about the cable's condition or its remaining service life. For this reason, the simple cable test is falling out of favor, and it is increasingly being replaced by the monitored withstand test. In addition to cable testing, this also includes a tan delta and/or partial discharge measurement, and therefore provides more in-depth information about the condition of the cable. The current state of the art permits a protective test with simultaneous diagnostics plus a well-founded, predictive statement about the condition of the cable. Bauer technology covers every measurement method from VLF cable testing through tan delta and partial discharge testing to monitored withstand testing. The market-leading True Sinus technology, developed by Bauer, provides a precise basis for significant and reproducible cable tests or condition evaluations based upon tan delta or partial discharge testing even for simultaneous measurements such as MWT or full MWT. It permits the least destructive cable testing and condition evaluation of medium voltage cables in compliance with VDE, IEC, and IEEE. Bauer's VLF, or very low frequency test, is based upon a sine curve with a frequency of 0.1 Hz and can be shown to be comparable with the results of the 50 Hz sinusoidal testing and diagnostics. This comparability has been comprehensively tested in practical, everyday situations by field measurements and has proven its value in numerous studies and field tests. The most important factor in VLF testing is the reproducibility of the measurement results. This means that the influence of the measurement system upon the measurement result is minimized and the results are therefore load independent, a clear advantage compared to other methods, as the only voltage shape simultaneous measurement of partial discharges, ton delta, and VLF testing are possible. The ton delta measurement provides information about water trees, damp and wet joints, and thermal and chemical cable aging. It indicates the presence of partial discharges. 3 parameters are needed for the ton delta measurement: mean ton delta, standard deviation, and delta ton delta. The standard deviation, in particular, provides a great deal of information. Prerequisites are a high ton delta precision of 1 by 10 minus 4 and a high resolution of 1 by 10 minus 6. Particular advantages are that the layout is the same as for the simple voltage test, and that it is possible to display the measurement results during the measurement, which allows diagnostics to be performed easily. The partial discharge testing provides information about the quality of fitting work and locates partial discharges in joints, cable terminations, electrical trees in XLPE cables, and PDs in paper insulated cables. The following equipment is required to perform partial discharge testing: a VLF voltage source, an appropriate coupling capacitor, and a PC to control the complete process. With this combination of measuring devices, the information can be found and the measurement results supplied as in the example given. Even the smallest of faults, for example an air pocket between the insulating body and the field control, can be highlighted using partial discharge testing. The partial discharge testing also provides a phase-resolved representation, which gives information about the type of fault. This phase-resolved representation of the air pocket in the picture leads us to suspect that the cable contains a non-conducting material that is not in direct contact with the metal electrode. We will now summarize all the measurement methods and their most important functions. VLF cable testing provides information about whether the cable is okay and is used during the commissioning of new or repair cables for use with a voltage of up to 3 by U naught. It is increasingly being replaced by the monitored withstand test. The ton delta measurement diagnoses the condition of the cable in terms of aging and moisture. The PD testing locates partial discharges, uncovers installation faults, and provides initial information about the type of fault. Bauer diagnostic systems include a VLF sinusoidal voltage source, ideally with integrated ton delta function, a coupling capacitor for the partial discharge testing, and Bauer VLF True Sinus technology. These systems range from smaller variants, such as the Frida TD or Viola TD, with PDTAT60 coupling capacitor and a PC for controlling the system, through alternative VLF voltage sources, such as the PHG for higher voltages and longer cables, to fully integrated diagnostics in the cable test vans, Titron or Transcable. This shows that today's diagnostic systems are already very compact, handy, flexible, and user-friendly. They further offer a high level of significance for various application cases. We can thus also refute the myth of complexity. In the third part of the series, we will look into the application in detail and use case studies to demonstrate the options for cable diagnostics.
Bauer, ensuring the flow.